Assalamu alaikum dear students. I hope that you all are doing well. I am Nausheen Mansoor and I am here to provide you guideline for the first assignment of mathematics for chapter number 1. Our objectives for this lesson are: today you will learn about quadratic equations, importance of quadratic equations and how to solve them. And at the end of this lesson, you will be able to solve exercise 1.1 of your maths book by yourself. Well, my first question from you guys is that what is an equation? Basically, equation is a statement that two quantities or two things are equal. For example, 2 plus 3 is equals to 5 is a simple equation, as everything on the left hand side is equals to the right hand side. But in algebra, we work sometimes with letters that represent numbers that are unknown or we have to figure them out. So we might have equations like this: 2x plus 7 is equals to 0 or 9y is equals to 81, where x and y are variables which are unknown. But 9x plus 2 is not an equation. It's just an algebraic expression or a polynomial. Since there are many types of equations, but our today's topic is about quadratic equations, so you should know the meaning of quadratic. By the way, what do you think? What is meaning of quadratic? Actually, quadratic comes from the Latin word quadratus, which means square. And also you should know that the word quad is just one of the Latin numeric prefixes, which means 4 or quarter or tetra. Now, before we further proceed, you should know about degree of an equation involving only one variable for today's lesson. Basically, the degree is the largest exponent of the variable of an equation, or the highest power of the variable of an equation is called degree of that equation. Here in this table for the first equation, you can see that 1 is the largest power of the variable, which tells us that degree of this equation is 1. The equation of degree 1 are called linear equations. And you also know that graphs of the linear equations are always straight lines. Now think about few practical examples of linear equations. Now for the second equation, you can see that highest power of the variable is 2. So what will be degree of this equation? 2. And equations with second degree are known as quadratic equations. Similarly, equations with third degree are known as cubic equations, and equations with degree 4 are called quartic equations, and equations of degree 5 are called quintic equations. But our topic is quadratic equations. But now I just wanna ask that why the quadratic equations are something we care about. One of the reasons is that quadratic equations are very useful to find parabolic paths of a projectile motion and to find the elliptic paths of the planet. Now, by throwing a ball or shooting a cannon are the examples of a projectile motion. And to find the parabolic paths, we need quadratic equations. This is the example of a projectile motion, and this is the shape of a parabola. And quadratic equations represents parabola graphically actually, and quadratic equations also represent circles and ellipses. So quadratic equations are very important. Now, to solve the quadratic equations, we need to know that how to write a quadratic equation. Basically, ax square plus bx plus c is equals to 0 is the general or standard way to write the quadratic equation, where a should not be equals to 0. And you should know something about these a, b and c. A, b and c are known as coefficients of the quadratic equations, where a is the coefficient of the first term or quadratic term, b is the coefficient of the linear or middle term, c is a constant or third term. Also, there is a condition on these coefficients a, b and c. A, b and c should always belongs to R. R means real numbers. So that means these coefficients can be under root 3 minus 5 by 7, 8. That means these coefficients can be irrational, rational, or integers. Also remember that while writing the standard form of the quadratic equation, there was a specific condition that a should not be equals to 0. Now, if a is equals to 0, what will happen? Basically, what is a? A is the coefficient of the square term or quadratic term or coefficient of the first term. If a is equals to 0, then above equation will no longer be quadratic. Instead, it will become a linear equation. That is why a should not be equals to 0 for the quadratic equations. For example, if a will be 0, then equations will become 2x minus 16 is equals to 0 and 4x is equals to 9. These are not quadratic but linear equations. But your first equation 2x minus 16 is equals to 0 is in the standard form and 4x is equals to 9 is not. Also, if b is equals to 0, then what will happen? And what is b, by the way? B is the coefficient of the middle term, or b is the coefficient of the linear term. If b is equals to 0, then this equation will become a pure quadratic equation, because the linear term has been eliminated. For example, in these two equations, x square minus 16 is equals to 0 and 4x square is equals to 7 are pure quadratic equations because there is no linear terms in these equations. And here first equation, x square minus 16 is equals to 0 is in the standard form, while 4x square is equals to 7 is not. And what if c is equals to 0? What will happen then? Think about it. Since now you guys are familiar with the standard form of the quadratic equations, so let's talk about how to solve them. There are mainly two ways to solve the quadratic equations. Our first method is by factorization, and there are three more steps to factorize an equation. First one is taking something common from the equation if it's possible. To understand this method, go through the example number 2 on page number 3 and factorize 5x square is equals to 30x. Now, second way to factorize the quadratic equation is by using algebraic identities. And if by algebraic identities it's not possible to factorize the given quadratic equation, then there is a third method, third way, that is a midterm break. And you have already learned these two ways in your previous class 9th in chapter 5. Now after factorization, the second method to solve the quadratic equation is completing the square method, which you will learn today. Okay guys, now let's solve the quadratic equation by factorization method. For that purpose, we will solve question number 2, fifth part of your first exercise 1.1. For that purpose, you can see that the given equation is not in the standard form and there is no square term in it. But you should know that if variables appears in the denominator, then it will be a quadratic equation. So first of all, we will transform the given equation into the standard form. For that purpose, take LCM on the right hand side. Now x minus 3 into x minus 4 is the common denominator. You know the drill. Now you will expand numerator and denominator by using the distributive law, x into x minus 4 and minus 3 into x minus 4. In the denominator and numerator will be simplified. Due to this minus sign, now inner sign will be changed. So we have got x minus 4 minus x plus 3 dividing by x square minus 4x minus 3x plus 12. Plus x and minus x are cancelled and we will solve like terms in the denominator. We have got left hand side as it is equals to minus 1 by quadratic expression. You can see that in the general form there is no fractions, so we will cross multiply them. 2 into a quadratic expression equals to minus 1 into x minus 9. By multiplying them we have got this. You can see that we need 0 on the right hand side, so move these two terms on the left hand side. So this is the required general or standard form of the given quadratic equation. Now you can solve question number 1, all the parts of your exercise 1.1. This is your homework. After transforming the given equation into the general form, now we will factorize it. To factorize this equation, you know that by using identities it's not possible, so we will choose method of midterm break. For midterm break, we will multiply the constant term with coefficient of the square term and we will get 30. Now think of all the factors of 30 to choose appropriate pairs so that by adding or subtracting them you should get the middle term. There are two pairs. By adding or subtracting them we are getting 13. So first of all we choose 2 into 15. Let's see what will happen. We need minus 13, so we will write minus 15 plus 2 is equals to minus 13. Since our middle term is 13x, so we will multiply x with 15 and 2. Now you can see that from first two terms x is common, from second two terms nothing is common, so we will take 1 as common. Now you can see that for the correct factorization or correct midterm break, these two brackets should be same. But here these two brackets are not same, so our midterm break is wrong. That means we have chosen a wrong pair. So let's choose the second pair and let's see what will happen. Now our second pair is 10 into 3 is equals to 30. For minus 13, we will consider minus 10 minus 3 is equals to minus 13. By breaking the middle term, we are getting 2x square minus 10x minus 3x plus 15 is equals to 0. You can see that from first two terms 2x is common, from second two terms 3 is common. By taking minus 3 as common, inner sign will be changed. Now you can see that these two brackets are exactly same, so our midterm break technique is correct. Now by taking common x minus 5, we are left with 2x minus 3 is equals to 0. So x minus 5 into 2x minus 3 is equals to 0 are the required factors of the given quadratic equation. Now remember that if product of two terms is equals to 0, then one of them must be exactly equals to 0. Think upon it. So here either x minus 5 is equals to 0 or 2x minus 3 will be equals to 0. From here we have got x is equals to 5 or x is equals to 3 by 2. These are the two values of the given variable, so our solution set will be 5 and 3 by 2. And these values of the given variable are known as roots or zeros of the given equation. Since our given equation was quadratic, so we are getting two roots. If degree of the equation is 1, you will get 1 root. If degree of the equation is 3, you will get 3 roots, and up to so on. Now you can solve question number 2 all the parts by using this technique. After understanding the method of factorization, let's move to our second method to solve the quadratic equations. There are two reasons for this method. Firstly, it's very difficult sometimes to choose a pair for midterm break. Secondly, there are some quadratic equations where we literally cannot think of pair of numbers, like it's really impossible to apply midterm break. For example, in this question x square plus 6x plus 7 is equals to 0, we cannot apply midterm break technique. So to understand the method, we are considering third part of question number 3 from your exercise 1.1, that is 11x square minus 34x plus 3 is equals to 0. One thing you should keep in mind that to apply any method, our given quadratic equation must be in the general form. So this equation is already in the general form. Now, for completing the square on the algebraic terms, we do not need constants. So our first step is shifting the constant to the right hand side. So we will get this. Second step is that leading coefficient of the equation should be 1. So dividing by 11 on both sides. Therefore, we have got x square minus 34 by 11x is equals to minus 3 by 11. Now our leading coefficient or coefficient of the first term is 1. Let's move to step 3. Step 3 is the main step of this method. Here you will have to do two things. Number 1, divide the coefficient of x by 2, and second thing is take its whole square. So step 3 is adding square of the half of the coefficient of x on both sides. That means add half of the 34 by 11 whole square on both sides. Now by simplifying half of the 34 by 11, we will get 17 by 11 whole square. So step 3 is half the coefficient of x, then take the square, simplify it and add it to both sides of the equation. So we have got x square minus 34 by 11x plus 17 by 11 whole square is equals to minus 3 by 11 plus 17 by 11 whole square. Now on the left hand side, this whole expression is a perfect square. By looking at the algebraic identity, if the middle term is negative, it will be the second identity. So by closing the identity on the left hand side, we have x minus 17 by 11 whole square is equals to minus 3 by 11 plus 17 by 11 whole square as it is. If you take this thing and open the square, you will get the same expression again. So you can try this. Now simplifying the right hand side. By taking the LCM, we will get 256 by 121. And you know that we are actually solving the given quadratic equation. That means we are finding values of the variable. Now to find x from the left hand side, we should get rid of the square. And for that, we will take the square root on both sides of the equation. So there will be a plus minus sign on the right hand side. And you know that if x square is equals to 25, then x will be equals to plus minus 5. Because equations of the degree 2 will give you two values for the variable. Now square and square root are cancelled. So we have got plus minus 16 by 11 on the right hand side. To find x, minus 17 by 11 should be on the other side. And by this plus minus, you should know that plus minus really means two different numbers, one with plus sign and other with negative sign. So we will split them out and we will solve them. So x is equals to 3 and from the other side x is equals to 1 by 11. So these are the required values of the given variable. Therefore, we have solved the given quadratic equation by completing the square method. So solution set is 3 and 1 by 11. And these values of the variable are known as roots or zeros of the equation. So now you can solve question number 3, all the parts by yourself. And this is your assignment, exercise 1.1. All the questions you can do by factorization and completing this square method. Thank you so much for listening to me. Allah Hafiz.